Good morning, students. Today's topic, Unit 5, Special Functions. The topic is Other Forms of Beta Function. Content, beta function, and other forms of beta function or transformation of beta functions. Beta function. Definition. If m and n are positive numbers, then the beta function is defined by the integral 0 to 1 x to the power of m minus 1, 1 minus x whole power n minus 1 dx, and is denoted by beta of mn. So beta of m comma n is integral of 0 to 1 x to the power of m minus 1, 1 minus x whole to the power of n minus 1 dx. This definite integral is called as beta function and is denoted with beta of m comma n, where m and n are positive numbers. Properties and other forms of beta function. Beta function is a symmetric function, that is beta of mn is always equal to beta of nm, where m comma n are positives. Beta of 5 comma 4 is equal to beta of 4 comma 5. For example, beta of 7 comma 8 is equal to beta of 8 comma 7. Beta of mn is 2 into integral of 0 to pi by 2 sine power 2m minus 1 theta cos power 2n minus 1 theta d theta. So it is another form of beta function. And also using this 2m minus 1 is let it be some p and 2n minus 1 is let it be some q, then we will have integral 0 to pi by 2 sine power p theta cos power q theta d theta is half into beta of p plus 1 by 2 comma q plus 1 by 2, which is obtained from this, that is 2m minus 1 is some p and 2n minus 1 is q. Beta of mn is integral of 0 to infinity y to the power of n minus 1 upon 1 plus y whole power m plus n dy. Another form, beta of mn is integral of 0 to 1 x to the power of m minus 1 plus x to the power of n minus 1 upon 1 plus x whole to the power of m plus n dx. So these are the different forms or other forms. So once again, other forms are beta of mn is always equal to beta of nm. Beta of mn is integral of 0 to infinity y to the power of n minus 1 upon 1 plus y whole power m plus n dy. Beta of mn is 2 into integral of 0 to pi by 2 sine power 2m minus 1 theta cos power 2n minus 1 theta d theta. Beta of mn is gamma of m into gamma of n all upon gamma of m plus n. It is also known as the relation between beta and gamma function. Beta of mn is integral of 0 to 1 x to the power of m minus 1 plus x to the power of n minus 1 upon 1 plus x whole to the power of m plus n dx. So these are the other forms of beta function. Property of beta function. Statement, beta of mn is always equal to beta of nm, that is beta function is symmetrical with respect to m and n. Proof. We have the definition of a beta function for m and n, that is beta of mn is integral of 0 to 1 x to the power of m minus 1, 1 minus x whole to the power of n minus 1 dx. Now to simplify, first we have to put 1 minus x as t. Now differentiating on both sides, the derivative of 1 is 0, the derivative of negative x is negative dx, the derivative of t is dt, but dx equal to negative dt. And we have to change the limits also. When x equal to 0, t equal to 1, when x equal to 1, t equal to 0. So thus the integral becomes negative integral 1 to 0 1 minus t whole power m minus 1 t power n minus 1 dt. Now interchanging the limits. So we will have integral 0 to 1, 1 minus t whole power m minus 1, t power n minus 1 dt. Now throughout the integration, just replacing t with x. The value cannot be changed because integral a to b f of t dt is integral of a to b f of x dx. The definite integral is a function of limits only. So thus we will have integral of 0 to 1 x to the power of n minus 1, 1 minus x whole power m minus 1 dx. It is nothing but beta of nm. So thus we will have beta of mn is always equal to beta of nm. For example, beta of 5, 4 is equal to beta of 4, 5. Other forms of beta function prove that beta of mn is integral of 0 to infinity y power n minus 1 upon 1 plus y whole power m plus n dy. We know that beta of mn is integral of 0 to 1 x power m minus 1, 1 minus x whole power n minus 1 dx. Let it be equation 1. So it is the main definition of beta function for with respect to m and n. Now putting x equal to 1 by 1 plus y or dx is negative 1 by 1 plus y whole square dy. That is which is obtained by differentiating on both sides. X derivative is dx, 1 by 1 plus y derivative is minus 1 by 1 plus y whole square into dy. Now also we have 1 minus x is 1 minus 1 by 1 plus y, which is equal to taking the LCM of 1 plus y. So we have 1 plus y minus 1. Clearly 1 will get cancelled. So we will have y by 1 plus y. It is the value of 1 minus x. So also when x equal to 0, we will have y equal to infinity. Because 1 plus y is 1 by x. So y value becomes 1 by 0. But 1 by 0 means infinity. When x is equal to 1, so we will have y value is 0. Because y by 1 plus y is 1 minus 1 is 0. That is y by 1 plus y is 0, which implies that y equal to 0. These are the new limits for y. So we are changing total independent variable x in terms of y. So here when x equal to 0, lower limit x equal to 0, y value becomes infinity. The upper limit of x is 1 here. When x is equal to 1, y value becomes 0. These are the new limits. Substituting all these values in equation 1, we get. So in equation 1, we will have beta of mn is integral of infinity to 0. Those are the new limits for y. Replacing the x value as 1 by 1 plus y, and 1 minus x value is y by 1 plus y, and dx value is negative 1 by 1 plus y whole square dy. Now simplifying this integrand. So we will have integral of 0 to infinity because we are neglecting minus here. So minus becomes here positive. So that the interchanging limits here. Infinity to 0 becomes 0 to infinity. And y power n minus 1 as a numerator, the denominator value becomes 1 plus y power m minus 1 plus n minus 1 plus 2. That is 1 plus y whole power minus 1 minus 1 minus 2. Minus 2 plus 2 get cancelled. So thus we will have y power n minus 1 upon 1 plus y whole power m plus n dy. It is a required proof of beta of mn. It is the other transformation of beta function. Don't forget, we will use this formula while doing the sums related to improper definite integrals. So the formula here, beta of mn is integral of 0 to infinity y to the power of n minus 1 upon 1 plus y whole power m plus n dy. Also, as beta of mn is equal to beta of nm, now we can write this formula as interchanging m and n. We will have beta of nm. So beta of nm is integral of 0 to infinity. Just n is replaced with m. So y power m minus 1 upon 1 plus y whole power m plus n dy. So it is the value of beta of mn and it is beta of nm. Other transformation, beta of mn is the integral of 0 to 1 x to the power of n minus 1 plus x to the power of n minus 1 upon 1 plus x whole to the power of m plus n dx. Solution. We know that beta of mn. So what is the formula of beta of mn? Integral of 0 to infinity x to the power of m minus 1 upon 1 plus x whole power m plus n dx. Here just dx is missing. Please note down. So is the formula just we have proved above. Now integral of 0 to infinity can be written as integral of 0 to 1 plus integral of 1 to infinity. Same integrand function, just here 0 to infinity is split as 0 to 1 plus 1 to infinity. So let it be equation 1. Now put x equal to 1 by y. So that dx is minus 1 by y square dy. In the second integral, we will get to change the limits also. That is x equal to infinity, y value becomes 0 because y is 1 by x, so that 1 by infinity is 0. When x equal to 1, we will have y value is 1. That is y equal to 1 by x, but x equal to 1, so we will have y equal to 1. These are the new limits. So thus we have integral of 1 to infinity x to the power of m minus 1 upon 1 plus x whole power m plus n dx is integral of 1 to 0, x is replaced with 1 by y and dx is replaced with minus 1 by y square dy. So on simplifying, just by taking the LCM on denominator, the LCM is y power m plus n. Clearly the fraction is reversed. So thus we will have integral of 0 to 1 negative. Here negative is removed so that we are interchanging the limits. 1 to 0 becomes 0 to 1. So y power m plus n upon y power m plus 1 into 1 plus y whole power m plus n dy. So thus we will have integral of 0 to 1 y power n minus 1 upon 1 plus y whole power m plus n dy. Just replacing y with x, so we will have integral of 0 to 1 x power n minus 1 by 1 plus x whole power m plus n dx. Because the definite integrand is a function of limits only. So just we are changing here y variable as x. Both are equal. So from equation 1, we will have beta of mn is integral of 0 to 1 x to the power of m minus 1 by 1 plus x whole power m plus n dx. As it is, we have written because just we have changed the second integral. The second integral value, now it becomes integral of 0 to 1 x power n minus 1 upon 1 plus x whole power m plus n dx. Now combining these two integrals, so we will have integral of f of x plus g of x into dx is integral of f of x plus integral of f of x dx plus integral of g of x dx is equal to integral of f of x plus g of x dx. That is using linearity property. So we will have integral of 0 to 1 x power m minus 1 plus x power n minus 1 upon 1 plus x whole power m plus n dx. So it is the required proof. Some important deductions. First one is prove that gamma of n into gamma of 1 minus n is pi by sin n pi. So we know that beta of mn. So what is the relation between beta and gamma function? Beta of mn is gamma of m into gamma of n upon gamma of m plus n. Putting m plus n equal to 1, that is m equal to 1 minus n. So we get gamma of n into gamma of 1 minus n upon gamma of 1, because m plus n is replaced here 1, that is beta of m is replaced, that is n is 1 minus n. So let it be equation number 1. So but we have by beta of mn integral 0 to infinity y power n minus 1 upon 1 plus y whole power m plus n dy. So beta of n comma 1 minus n is integral of 0 to infinity y power n minus 1 upon 1 plus y dy, as integral of 0 to infinity x power n minus 1 by 1 plus x dx is pi by sine n pi. So now this value becomes pi by sine n pi. So for n less than 1, it is the value pi by sine n pi. But what is the value of beta of n comma 1 minus n? From equation 1, we will have gamma n into gamma 1 minus n is pi by sine n pi. So simple. So once again, just given beta of mn is gamma of m into gamma of n by gamma of m plus n. Just we have to replace m plus n as 1. So that m is 1 minus n. So we will have gamma of n into gamma of 1 minus n. Just we are replacing here m with 1 minus n whole upon gamma of 1 because m plus n value is 1. That is beta of n comma 1 minus n. M is replaced with here 1 minus n. Also we will have beta of mn is always equal to beta of n comma m. So what is the property? Symmetric property. So we have beta of mn is integral of 0 to infinity y power n minus 1 upon 1 plus y whole power m plus n dy. And we will have beta of n comma 1 minus n. It is the value of integral 0 to infinity y power n minus 1 upon 1 plus y dy. But what is the value? It is nothing but pi by sine n pi. So we have already learned this in lower classes. So pi by sine n pi when n is less than 1. But from equation 1 we will have gamma of n into gamma of 1 minus n is pi by sine n pi. Hence proved. Now prove that gamma of 1 plus n into gamma of 1 minus n is n pi by sine n pi. Just we have proved gamma of n into gamma of 1 minus n is pi by sine n pi. Now multiplying both sides with n, we will get, that is n gamma of n is gamma of 1 minus n is n pi by sine n pi, which is obtained just by multiplying with n on both sides. But what is n gamma of n? Which is nothing but gamma of 1 plus n, because we will have gamma of 1 plus n is n gamma of n. So always gamma of n plus 1 is n gamma of n. Just here n gamma of n is replaced with gamma of n plus 1 or 1 plus n. So it is the required proof. To prove that integral 0 to pi by 2 sine power n theta cos power n theta d theta is gamma of m plus 1 by 2 into gamma of n plus 1 by 2 upon 2 into gamma of m plus n plus 2 by 2. We know that beta of pq. So what is beta of pq? Integral of 0 to 1 x power p minus 1 into 1 minus x whole power q minus 1 dx. Let it be equation number 1. Just we have changed mn as pq. So it is nothing but gamma of p into gamma of q by gamma of p plus q. It is the relation between beta and gamma function. So putting x equal to sine square theta, so that differentiating on both sides, dx is sine square theta derivative is 2 sine theta, and then sine theta derivative is cos theta d theta. So substituting these values in equation 1, thus the beta of pq becomes integral of 0 to pi by 2 sine square theta whole power p minus 1, 1 minus sine square theta whole power q minus 1 dx is 2 sine theta cos theta d theta. So just here, which is obtained by replacing x as sine square theta and dx as 2 sine theta cos theta d theta. Limits also changed here. 0 to 1 limits becomes 0 to pi by 2. Because when x equal to 0, sine square theta is 0, implies that theta is 0. When x equal to 1, sine square theta is 1, sine theta is 1, so that theta is pi by 2. Because 1 is replaced with pi by 2, sine pi by 2, applying sine inverse on both sides, theta will becomes pi by 2. So new limits for theta are 0 to pi by 2. Don't forget to change the limits. Whenever we replace another independent variable, we have to change the limits of the definite integral also. So on simplifying, we'll get 2 into integral of 0 to pi by 2 sine square theta whole power p minus 1 is a sine power 2p minus 1 theta. It is 1 minus sine square theta. But what is 1 minus sine square theta? Cos square theta. Cos square theta whole power pq minus 1 is a cos power 2q minus 1 theta. So on simplifying, so we'll get just taking 2 on left hand side or dividing both sides with 2. So it is the required value. So beta of p comma q is gamma of p into gamma of q by p plus gamma of p plus q. Now putting 2p minus 1 as m and 2q minus 1 as n. That means p is m plus 1 by 2 and q is n plus 1 by 2. Substituting these values in this, so p is m plus 1 by 2 and q is n plus 1 by 2, we will get 0 to pi by 2 sine 4 n theta cos 4 n theta d theta is gamma of m plus 1 by 2 into gamma of n plus 1 by 2 whole by 2 into gamma of m plus n plus 2 by 2. So important formula, don't forget, integral 0 to pi by 2 sine 4 m theta cos 4 n theta d theta is gamma of m plus 1 by 2 into gamma of n plus 1 by 2 whole upon 2 into gamma of m plus n plus 2 by 2. So these are the other forms of beta and gamma functions. For any queries, for any doubts, please contact. Thank you.